Okay, let's verify this identity. You'll notice that we have a fraction equaling a fraction. Remember, the goal here is to only work with one side of the equal sign because we're trying to prove that this equals this. Our goal is not to solve for x. If we were trying to solve, we would probably think we should cross multiply, but that is not what we're going to want to do here. We're going to want to manipulate this left side with our identities to make it look like the right side. Now, one option I hope you see is this 1 minus sine of x. Anytime you see a 1 minus sine of x or 1 minus cosine of x or a 1 plus or minus any trig function, think Pythagorean identities. How can I make this into a Pythagorean identity? I cannot change anything out yet because I need them to be squared. So what I can do is I can use what I know about the difference of two squares and multiplying by a conjugate. A conjugate is when we just change the sign here. So if I multiplied this first fraction right here, this 1 minus sine of x over cosine of x, if I multiply that by the conjugate, 1 plus sine of x, both on top and on bottom, because I can't just go around multiplying something, I have to multiply by a 1, and this equals 1. So I'm not changing the value here, I'm just multiplying it by a very interesting looking 1. Now if I multiply these two together, remember the goal was to create the difference of two squares, and I have. So I end up with squaring the first term, I get 1. It's always the difference of two squares, and squaring the second term, so sine squared of x. And on the bottom, I end up with, cosine of x. Sorry, let's get back. So I multiply this times this, and I get this. Now I want to multiply this times this, so I'm going to get cosine of x times 1 plus sine of x on the bottom. Now I don't need to multiply these out because this I like. Notice it's here on my goal. So I want to kind of leave this out unless I need to multiply it later. Here I have now created a Pythagorean identity, and I can swap it out. So if you come look right here, 1 minus sine squared of theta. So if I subtract sine squared from both sides, I end up with 1 minus sine squared on the right, and on the left I have cosine squared of theta. So I can replace this guy right here with cosine squared of theta. So let's do that. So this right here gets replaced with cosine squared of theta, and then on the bottom I have cosine of x times 1 plus sine of x. Now I have two cosines on top. If you need to, you could separate it and write cosine of x times cosine of x. And on the bottom I have a single cosine. So I can cancel out one of these cosines and one of those. And so this is now a 1. And notice what you have right here. Cosine of x over 1 plus sine of x. And that's what we have. Cosine of x over 1 plus sine of x. And that equals our goal side over here on the right. And so we have verified this identity.